Hello, how are you? I hope you're doing good. Welcome to today's math episode. Are you ready? Today we are going to talk about finding the nth term of a geometric sequence and determining the geometric means between two given terms of a geometric sequence. But before we start, let me just give you a few reminders. First, prepare your pen, paper, and your printed module. So as I discuss, take note of the important concepts. Second, focus. You have to be attentive. So whatever you're doing right now, set aside them first and focus on our discussion. In your printed module, you will find there the pre-assessment test, review, introduction and discussion, learning task, generalization, enrichment activities, and post-assessment test. At the back page, you can find there the key answer. But may I please remind you to answer all the activities in your module with utmost honesty. Take note that the key answer is provided to support and guide you in learning. After answering each task, look at the key answer and check your answers. Put a check mark if your answer is correct and put an X mark if your answer is incorrect. Be reminded also to use separate sheets for your answers. So at this point of time, I know you are ready. Let's have a brief recap of the previous lessons. Recall that a geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by the same constant known as the common ratio. To further recall, determine the common ratio of this sequence. What is the common ratio? You're right, the common ratio is 2. How do we determine the common ratio? Choose any of the term of the sequence, then divide it by the previous term. Example, for this sequence, choose 20 divided by 10, that gives us 2. Again, choose 80 divided by 40 and that is equal to 2. Thus, the common ratio of this sequence is positive 2. Moving on here, we have this number sequence 3, 6, 12, 24 and then ellipsis, which means the sequence keeps going. This sequence is geometric because a new term is produced by multiplying the previous term by the same number. In other words, take 3 and get the next term by multiplying by 2 to get 6. The 6 gets multiplied by 2 into a 12. Then multiply 12 by 2 again to get 24. So it's a geometric sequence and the common ratio is 2. Now, what if somebody would ask, what's the 11th term? Well, one way to do this is to keep multiplying by 2 until we find out what the 11th term is. But let's find a general way to do it. Let's illustrate this sequence using a table. In the first column, let's write what the number of the term is, like 1, 2, 3. But let's use a slightly different notation. Instead of 1, let's write a sub 1. Instead of 2, let's write a sub 2, and so on. In the second column, let's write the terms. So the first term at a sub 1 is a 3. The second term at a sub 2 is 6. But we get that 6 by multiplying the 3 by the common ratio, so let's just write 3 times 2. Now, if I take that term and multiply it by the common ratio, I'll get the third term. So that would be 3 times 2 again. In the same way, the fourth term at a sub 4 is going to be 3 times 2 times 2 times 2. Now, instead of writing all of these 2's, we can use an exponent. So, we can take that fourth term, 3 times 2 times 2 times 2, and write that more simply as 3 times 2 to the third power, or raised to 3. The term before that would be 3 times 2 raised to 2. Again, the term before that, which is just 3 times 2, using an exponent, we will write that as 3 times 2 raised to 1. Now, if we keep using exponent, the first term, which is 3, will be 3 times 2 raised to 0. Since 2 or any number raised to 0 is just 1. Now, let's take a look at exponent and the number or position of the term. What is their relationship? For the first term, a sub 1, the exponent is 0. For the second term, a sub 2, the exponent is 1. For the third term, a sub 3, the exponent is 2. What are we doing here? We are taking the number of the term, subtracting 1 from it, and making that the exponent of the common ratio. In other words, the exponent of the common ratio is less than the position of the term. So that means if we want to find a term, let's say that term is n, or the nth term, let's set that equal to 3 times 2, and my exponent is 1 less than the number of the term. If the number of the term is n, then the exponent is n minus 1. Now we've got a general rule for this sequence. So if we want to find the 11th term, all we have to do is replace n with 11. So that means we will have 3 times 2 raised to 11 minus 1. Simplify that, we have 3 times 2 raised to 10. 2 raised to 10 is 1024. Multiply it by 3, that gives us 3072. Therefore, the 11th term, or a sub 11, for this sequence is 3072. So, now that we've got a rule for this sequence, let's see if we can make a rule for any sequence. We said that the nth term is 3, which was the first term, times 2, which was the common ratio raised to the power n minus 1. But instead of writing 3 for the first term, let's just use the notation a sub 1. And instead of writing 2, which was the common ratio, let's write r. And the exponent is going to be n minus 1. With that illustrative discussion, we can say now that the nth term for a geometric sequence with first term a sub 1 and a common ratio r is given by a sub n is equal to a sub 1 times r raised to n minus 1. So, if you're given a geometric sequence and you're asked to find terms, you can just plug in or substitute the numbers into the general formula. Now, let's do this. Write the rule for the nth term of the sequence, -2, 6, -18, 54. Then, find the 10th term. The first thing that we do is to identify the given. Do we know the first term? Yes, the first term is -2. Do we know the common ratio? Yes, the common ratio is -3. Therefore, the rule for the nth term for this sequence is a sub n is equal to -2 times -3 raised to n minus 1. Now, to find the 10th term, just plug in 10 to n, then simplify. Therefore, the 10th term for this sequence is 39,366. Now, let's move on to geometric means. Note that knowing the nth term of a geometric sequence will help you to determine geometric means a lot easier. But what are geometric means? Geometric means are terms in between two terms of a geometric sequence. In the sequence 1, 2, 4, 8, and 16, 2, 4, 8 are the three geometric means between 1 and 16. To solve for the geometric means, the first step is to solve for the common ratio. Example: insert three terms between 2 and 512. Note that since we will insert three terms, then there will be 5 terms in all. Let us identify the given values. A sub 1 will be equal to 2. A sub 5 will be equal to 512. And n is equal to 5. Let us use the general formula. Then substitute the given values. A sub n now becomes a sub 5. And a sub 5 is equal to 512. A sub 1 is 2 times r raised to n minus 1, or 5 minus 1. Let us then simplify. 5 minus 1 is equal to 4. To isolate r raised to 4, let's divide both sides by 2. 512 divided by 2 is equal to 256. Let's solve for r. Take the fourth root of each side. The fourth root of 256 is equal to positive and negative 4. There are two values of the common ratio, thus we will also have two sets of geometric means. Now, if r is equal to positive 4, the second term is equal to 8, the third term is equal to 32, the fourth term is equal to 128. So, if r is equal to positive 4, then the three geometric means between 2 and 512 are 8, 32, and 128. If r is equal to negative 4, the second term will be negative 8, the third term will be positive 32, the fourth term will be negative 128. So if r is equal to negative 4, then the three geometric means between 2 and 512 are negative 8, 32, and negative 128. Get it? Let's try another one. Insert two terms between 6 and negative 162. Since there are two missing terms, then there are 4 terms in the sequence. Let us identify the given values. What is the first term? You're right. The first term is equal to 6. How about the last term? Correct. The last term is equal to negative 162. And the number of the terms is equal to 4. Let us use this formula. Then substitute the given values. So a sub n now becomes a sub 4, and a sub 4 is equal to negative 162. A sub 1 is 2 times r raised to n minus 1, or 4 minus 1. Let us simplify. 4 minus 1 is equal to 3. To isolate r cubed, let's divide both sides by 6. Negative 162 divided by 6 is equal to negative 27. Now, to solve for the value of r, we need to extract the root. Take the cube root of each side. The cube root of negative 27 is equal to negative 3. The cube root of r is equal to r. Therefore, the value of r is negative 3. Now, with that value of r, what are the two geometric means between 6 and negative 162? You're right. The two geometric means between 6 and negative 162 are negative 18 and 54. That ends our discussion. I hope the examples are clear to you. You may now work on your printed module, where further discussion and additional examples are provided. However, if there are concepts that are not fully clear to you, you may ask or seek help from your elder siblings, your guardian, or parents. There you go, our dear learners. Thank you for watching, listening, and participating today. Don't forget to watch and listen again to our next episode on Geometric Series. This is your teacher Robbie telling you that life without mathematics would be impossible. So learn to love math and enjoy learning.